Welcome to the Explainer. Okay, today we're embarking on a seriously fascinating digital excavation. We are going to reverse engineer a highly dense, totally cryptic snippet of executable code that is just unlike anything you'd normally see in standard software development. Today, we're decoding the Cosmic Love script. We're going to take this single, continuous block of code, literally just a string of commands mashed together into one incredibly efficient line, and break it wide open. We're going to see exactly how it operates, how it thinks, and how it somehow manages to weave abstract philosophy with rigorous, hardcore mathematical logic. So if you're fascinated by code that acts almost like a living organism, well, you are definitely in the right place. Let's get into it. Okay, let's dive into this. Cosmic Love is the solutions for everything. Now, at first glance, you might think you're just looking at a line of poetry, right? Or maybe some kind of philosophical mantra left in the comments. But what's absolutely incredible here is that this phrase isn't just poetry. It is literally a core text string variable, assigned the letter C, hidden deep inside a rigid, highly mathematical Python engine. This is the script's core message. The author of this code deliberately hard-coded this specific phrase into the machine's memory, right before executing a series of intense computational loops. It creates this beautiful juxtaposition, the cold, calculating nature of computer science, wrapping itself around a warm, deeply human sentiment. But as you'll see, this string is way more than just a quirky comment. It's an actual structural component of the script's final output. So to see how this builds from the ground up, let's put on our digital detective hats for a second. The chronological execution of this script is just an absolute masterclass in self-reliance. Before it even attempts to run its core logic, it checks the environment to ensure its own survival. Step 1. It uses a basic shell command, command v python 3, just to see if Python is even installed on the machine. And if it isn't, the script doesn't just crash and throw an error like most programs would. Look at step 2. It actively triggers an installation using Alpine Linux's package manager, and it does it completely silently. It essentially builds the exact environment it needs to live in. Then, in step 3, it reads for external input variables, which are labeled N and B. And finally, in step 4, it launches right into an inline Python execution. It's autonomous, it's self-healing, and honestly, it's just incredibly efficient. Now, you might be wondering, what happens if those external inputs, variables N and B, aren't provided by the user? Well, the script is designed to safely default both N and B to the exact integer of 16. So the really crucial point here is that this number acts as the mathematical foundation for everything that comes next. It essentially sets the boundaries for the upcoming processing loops. And 16 isn't just a random choice. In computer science, it's a power of 2, which is totally fundamental to hexadecimal structures and memory allocation. Alongside this, the script quietly establishes a modulo constant, variable m, set to 2047. Together, this foundational number 16 and that constant 2047, they create the strict geometric borders of the digital sandbox our script is about to play in. All right, now things get mathematically intense. We've isolated the absolute mathematical engine of the script here. It's a lambda function assigned to the variable e. This function acts as a highly custom, super complex checksum. Basically, whenever the script needs to verify data, it passes that data straight through this function. It iterates through every single character, applies a shifting multiplier using powers of 257, and then crunches the whole thing down using a massive modulo of 10 to the power of 18. To put that simply, this function securely hashes bytes and strings into massive, highly unique 18-digit numeric footprints. It's like a digital fingerprinting machine, ensuring that even the absolute tiniest change in the data results in a completely different 18-digit number. So what exactly is it fingerprinting? Well, the script runs these really intense nested loops, a for u loop and a for k loop, which are limited by that number 16 we talked about earlier. And as it loops, it constantly mutates 5 specific variables. We've got S, W, D, Q, and H. Notice the calculations here. We're looking at modulo sums, bitwise shifts, and state mutations. For example, W is recalculating itself by shifting bits to the right based on the loop index. D acts as a direction tracker, just flipping back and forth between positive and -1. And Q forces a state mutation by combining the other variables and wrapping them around a modulo of 3. It's essentially a complex state machine. Actually, scratch that. It's more like a digital loom, generating a sprawling array of data called P. It's literally weaving a tapestry of numbers, dynamically shifting and recalculating itself thousands of times in just a fraction of a second. But what's really wild here is that this script reveals a bizarre kind of digital self-awareness. It actually executes an open.read command on its very own source file. It is literally looking at itself in the digital mirror. It checks its own string length to see how large it is, and then, remember that fingerprint engine we just looked at, function E? It runs that checksum on its own code. It bundles all the self-analysis into a metadata dictionary under the perfectly named key self. And then, out of nowhere, it throws us a total curveball. It adds another key called U and defines it as the string all bubbles. I mean, come on. We have this hyperlogical, rigorous self-profiling sitting right next to an entirely whimsical phrase. It's such a fascinating look at the unique personality the developer embedded into this raw logic.
And this brilliantly illustrates a core principle of reliable computer science, idempotency. When data S is passed through function L one time, compared to when that exact same output is passed through function L again, the script is actively verifying its own stability. In the code, this is written as the check. Fix equals T1 equals T2. It's basically asking the system, hey, if I process this data twice, do I get the exact same result as if I processed it just once? If the answer is yes, the system is completely stable. It means the function has settled into a final, unchangeable state. It's a rigorous self-diagnostic test to ensure that the cosmic love data string isn't somehow corrupting the mathematical output upon repeated loops.
Finally, all of this crazy computation converges. Let's unbox the final JSON dictionary, which is labeled D in the script. This right here is where the cold math and the cosmic message completely unify. Notice that EQ line? That is a mathematical representation of the idempotency we just discussed. The solution of solution equals solution. And look at the diagnostic values at the bottom. Fix 1, meaning the fix is in and totally stable. ABS 1, confirming absolute validity. Loss is an array of zeros. And most importantly, bug 0. The script has rigorously tested its own environment. It mathematically generated a complex state, verified its own source code, confirmed its mathematical stability, and reported back a perfectly clean bill of health. 0 bugs, 0 loss, just flawless execution. But all of this brings us to a massive, lingering question. Once the script finishes all this incredible work, it takes that perfect, zero-bug JSON output and writes it to a local file on the hard drive named solution_0.clcert. Now, the extension .clcert implies it is a certificate, a cryptographic proof of everything we just analyzed. But a certificate is really only useful if there is a gatekeeper asking for it, right? So I leave you with this. What larger ecosystem, what mysterious server or secondary program is out there waiting to validate solution_0? We've decoded the Cosmic Love script today, but it really seems like this executable is just one key to a much larger unseen door. Thanks for joining me on this explainer, and keep your curiosity sharp.